Good morning, everyone. This is going to be a quick demo of using some of the features of NumPy, some of the array features, which we'll use for the new lab 8, this Wednesday. As I've said before, the textbook is really going to be the best source of this information because it's all laid out in kind of a searchable format, or the NumPy docs, just because there's so many new functions and such a big learning curve that I don't expect you to keep it all in your head. It's something that you just need to understand what types of things are possible to do, and then you can go figure out the exact syntax or the exact function call to do what you want from the textbook or from the NumPy documentation. So first, we're just going to cover creating some arrays, and then we're going to go over reshaping and what that means, and then appending some arrays together. And that should be a rough overview of what you need for the new lab. So there's so many different ways to create an array in NumPy. First way is just using empty, where you give it the shape. So we'll say our array is equal to np.empty. And we'll say we want this to be a 5 by 2 array, so like a matrix. And we'll just print that. Oh. There we go. This first argument needs to be a tuple, saying the size of the array. So this 5 by 2 means that it has 5 elements in the first dimension and 2 elements in the second dimension. When it's a 2D matrix, you can think of this as rows by columns. But when the matrix gets bigger, it's harder to conceptualize that way. And so I encourage you to just think of it as first dimension, second dimension all the time. And so we can see that down here. We've got 1, 2, 3, 4, 5 in the first dimension, and then each one is 2 elements deep. You can see these elements are just filled with random junk. What this is just whatever happened to be in memory before the array created an object at that memory location. So this will always just be random stuff, random numbers. You've no idea what it's going to be. And so usually when you create something with empty, you override the values really quick. Another option is zeros. This is going to zero everything in memory. So give us the same array, except for everything's been zeroed. It's still a 5 by 2. Third, there's ones, if maybe you wanted to then multiply by something. So you can see all of the ones. And then there's also a range, which is really similar to the built-in Python range that you all have gotten good using for your for loops. So a range is going to take in a stop. Let's say we'll go from 4 to 10, and we're going to increment by 2 each time. 4 to 11, since the end is not inclusive. And that gives us 4, 6, 8, and 10. Notice this is just a one-dimensional array. So if we look at the shape of it, with our array.shape, it's 4, comma, and then nothing. So that's saying it's got 4 elements in the first dimension and then nothing in the second dimension. There is no second dimension. And we can see that is correct. Another way to create an array, which could be helpful for some of the labs, is from a function. So let's create our function. We'll call it square. And we'll take in an x, and we'll return x squared. So from function, looks like it takes in the function first and then the shape that it wants it to be. So we'll use our function square num, and the shape will be, oops, we'll say 5, comma, and then no keywords. Let's see if this works. Sweet. So it gives us an array of 5 in the first dimension. And it starts with 0, then 1, then 2, then 3, then 4, but it passes them to our function, squares them, and then creates the array from that. So you can get a lot more complicated with this. You could take in x's and y's, and then we could say return x squared plus y. And we'll make this a 5 by 3. And so you can see that 0 squared plus 0, here's 1 squared plus 1, and then, or sorry, 0 squared plus 1, 0 squared plus 2, and then so on and so forth. So you can see this is like a really powerful way to put custom data in here, depending on the X, Y, Z, Q, R, et cetera, as many dimensions as you want to go deep into this. It gets a bit hard to think about after 2 dimensions, but only some problems will require that. Cool. So that is creating arrays. Let's change this back to something easier to conceptualize. Oh, final way to create an array is just np.array, and then you pass in a Python list. So we'll do a 2D list. We'll say we want 3, 4 here, and then maybe 5, 6, and then one more, we'll do 7, 8. Let's take a moment to think of what this array is going to look like printed out from NumPy, and then also think of what the shape is. Sweet. So we can see we've got 3 in the first dimension, so 3 rows, and then 2 columns, 3, 4, 5, 6, 7, 8, and it lines them up nicely. Now, if we wanted to change the shape of that, maybe make it like a 2 by 3 instead of a 3 by 2, we could say array2 is equal to array.reshape. And we'll pass in, we want this to be now a 2 by 3. So here we can see it went from a 3 by 2 originally to now it's got 2 rows with 3 columns. This can be helpful for reshaping certain types of data to make it make more sense, or to line stuff up the way you need it to, or for just practice problems in the lab. Another thing you can do besides just reshaping an array is flatten it. So flatten takes in no arguments. And this is just going to say, okay, take your big matrix and just flatten it, turn it into a 1-dimensional array. So here we flattened our 3, 4, 5, 6, 7, 8 into 3, 4, 5, 6, 7, 8, just all as one. Any guesses on the shape of this one? I think you should think of what they're going to be, and we'll print them out. Six by empty, because there's only 1 dimension. Finally, there's append. And append just concatenates 2 arrays. Rather than appending an element to the end of an array, you can append a whole array to an end of an array, I believe. So we can make our array 3. It's going to be the 1s, and we want 5 of them. And then No attribute append. Extend? Nope. It's not an object, or it's not a class method. It is just an NP method. So that means is we say numpy.append, and we pass in the array, and then we pass in the other values. So array2. And that gives us this thing down here where we've got all the ones from array3, so 5 ones. And then we've appended, excuse me, the flattened array2. So we've appended this array to the end of this array and made this whole mega array. So that should be about all that you need to get started on the new lab. Please read the textbook. That's going to be the best source of information for all of this. It's very searchable. And once you know where all that stuff is, even if you just skim it, it'll be a lot faster to get through these labs. All right. Thank you all. I'll see you on Wednesday.